Right, so here's another specified prac looking at the light intensity on a solar panel. Are we
Thank
ready?
you, Miss. So, lovely topic this one. We are looking at renewable energy. Really important topic, solar panels, because we can produce electricity without carbon dioxide, and it is also an infinite resource. We're going to look at today the effect of light intensity using my lamp on the energy production of this solar panel. So, quick run through of our equipment. We've got a voltmeter, a solar panel, and a lamp. Okay, and finally, just to do some important measurements, a 1 meter ruler. My independent variable, okay, I want to be changing the light intensity. I'm going to do this by moving my lamp back and forth, okay. What this is trying to model is the power of the sun at different times of the day, okay. We know that at midday, perhaps the sun is stronger, so it'd be nice and close, whereas at night time, our solar panels are a little bit useless because there's no light shining on them. My dependent variable, what I'm going to measure, is the voltage produced each time. Control variables, same solar panel, same lamp, same power source, and I'm going to try my best to keep it shining at the same angle each time. It is tough because I have to do some managements, but I've got to get on with that really. We can maybe talk about that in inaccuracies. So first thing, I've got my table of results. I'm going to move my lamp far from the solar panel a distance of 20, 40, 60, 80 and 100 centimetres. Okay, so let's start off. I'm going to turn my lamp on and then I'm going to measure out my distance with my meter ruler. Need to go back a little bit. Again, this is an inaccuracy really because I can't know exactly the distance. It's quite tough with a meter ruler. And that is telling me I've got 0.52 volts. So I'm going to come down to my results table now, and I've got 0.52 volts. I'm then going to repeat it at 40 centimetres. So I'm going to move it back roughly, and then 60, and it's showing me 0.47. And then I'm going to repeat that at 60, 80 and 100, moving it back. And then we can see I'm going to do it at 2. I'm going to do it all again for each one. And I'm going to do it all again for a third time. And finally, I'm going to calculate a mean by adding them all up and dividing by how many there are. So we're going to go to the time lapse now because you know what's going on. And we'll have some results for you at the end.
Right, back for some analysis.
So with the help of Miss Hills and Miss Lahan, we've finally done, we've got our results. What I want you to notice is that Miss Lahan, she is excluded an anomaly there. Okay, naughty piece of data, we don't want it in there. So she's shown it, but she's then crossed it out. Now we've got to think about why have we got an anomaly? What inaccuracies could we possibly have that could affect this experiment? First thing, and I want you to notice, is that my voltmeter is currently showing voltage. The reason for this is we're in a bright room, as you can see, so my solar panel is going to be working. Another thing you'll notice is that my lamp moves up and down, it twists, so perhaps when I was moving it back doing my measurements, I may have got it slightly tilted up or down, which could cause for the results to go up. And finally, we've got fluctuations in the distance. It's quite hard with a meter ruler to find exactly that distance. So my one improvement, first of all, for my solar panel, I'm going to do this in a darkened room. My second one, I'm going to use a fixed lamp to make sure that the angle is the same. And finally, I'm going to use a laser distance measure to get it at this similar point. Now finally, if we were going to look at a graph, I would be plotting my distance from the lamp along the x-axis, that's the bottom, because that's my independent variable, and then I'd have my mean voltage up the side. And as you can see, as my distance from the lamp increases, my mean voltage decreases at a steady rate for our results. So hope you enjoyed the video. Subscribe.
And like.